Hi all, this is Lakshmi, working as Assistant Professor in the Department of ECE at SNSCT. So today I'm here to discuss about the lecture series on smart sensors and devices, and the topic which I'm going to discuss today is variable reluctance transducer. So before discussing in detail about this VR transducer, that is variable reluctance transducer, we must know what is an inductive transducer. So we generally we have heard about this term inductance. So this basically it works upon the electromagnetic induction principle. So what is electromagnetic induction is? So we know that it is when there is any change in the magnetic field cross the current carrying conductor and EMF is induced. So that is called electromagnetic induction. So this inductive transducer works on the principle of electromagnetic induction. So here the self-inductance is varied to measure the various physical parameters like force, pressure, velocity, speed, etc. And one good example of the inductive transducer is LVDT, which is linear variable differential transducer. So this works based on the principle of electromagnetic induction, which means if there is any change in the magnetic field across a current carrying conductor, an EMF is induced. So now talking about the term variable reluctance. So the term reluctance, we can compare it to the term resistance in the conductor. So we know that the term resistance in a conductor is the opposing character of the current. So when a current is flowing through a conductor, the resistance will oppose the flow of conductor. Similar to that resistance, here we call a term reluctance. So this opposes the magnetic field. So this is also an opposition to the production of magnetic field in the circuit. So the externally energized transducer is our variable reluctance type. So here the magnetic circuit will be broken by an air gap. So based on the mechanical movement that is used to change the air gap, we can calculate the displacement of the target material. So the changing that reluctance or the opposition to the production of magnetic field will be done with the help of this variable reluctance transducer. So the working principle behind this variable reluctance is as we have discussed. So the flux path through the air is much higher reluctance path than the path through the ferromagnetic material. So I have already discussed that this reluctance can be compared with the term resistance in an electric circuit, where you can compare the flux as the electric current and the air being the high resistance, while our ferromagnetic material like the copper connecting wires is of low resistance. So the reluctance of the air, which depends on the length of the displacement transducer, is modified by the movement of the ferromagnetic plate. So this is a variable type which consists of a coil wound on a ferromagnetic core, and the displacement which is to be measured is applied to the ferromagnetic target. So as I told, so here we could see that this is the air gap and this is the target ion. And ion material, a ferromagnetic material which is wound over a coil, and this based on the movement of this target ion. If we move this, the air gap here will increase, which means that it is the opposing the magnetic field. That is, the reluctance is high here. It is opposing the magnetic field. So air gap will increase. So this is the principle behind this VR sensor. So based on this air gap, we can calculate the movement or displacement of a particular target material. So, and also one more thing to be kept in mind here is the target material will not have any physical contact with the core on which it is being mounted. So that will be separated by an air gap. So the reluctance of that path will be determined by the size of your air gap. And there is a formula for self-inductance of the coil, which is given as L is equal to N squared by Ri plus Rg, and N is the number of turns, Ri is the reluctance of the ion parts, and Rg is the reluctance of the air gap. And the benefits of the variable reluctance transducer is that it is of low cost, robust, and speed high, and it requires only few wiring connections. It is highly reliable, and also it is having self-generating electrical signals, and no external power supply is required. So they have the ability to operate in high temperature applications. And the drawback or it what happens is the signal strength will get decreased as the wheel rotation slows. So in case of angular displacement, if the wheel rotation is slowed down, the strength of the signal is also getting reduced. So this is one disadvantage of the VR sensor. And the applications, they are mainly used as the proximity sensor, which is used to determine the position, and in crankshaft position in automobile sector, and in speed sensors in the automobile transmission, and also in engine control unit or the transmission control unit uses the sensor to determine when to shift from one gear to the next gear. So today's assessment illustrate the working principle of VR sensor, that is variable reluctance sensor. So as we are told, so this is the target material made of iron, and this is a ferromagnetic material with the Umbo coil, and based on the movement of this target material, the air gap will either increase or reduce, which will affect the reluctance path of this material, so that it opposes the magnetic field. So based on the air gap, we can measure the displacement of the particular object. Thank you.